Okay, so today we're going to be looking at the regression analysis method of cost separation and cost estimation. Before we go on, please subscribe to our YouTube channel and also share our videos and like them just to support our work. All right, thank you very much. Okay, so we'll be looking at the same question we use for the high and low method. But before we go ahead, let's talk about some difference or differences in using the regression analysis and the high and low method. One major difference is that the high and low method uses just the highest level of activity and the lowest level of activity. However, regression analysis uses all the data in the information. So it uses all the data. And so regression analysis gives us a more exact or accurate figure than the high and low. All right. So the high and low is more of an estimation, but the regression analysis is more of an exact figure. All right. So the same example that was used for the high and low method is what we're going to use for the regression analysis also. Okay. So let's move on. Now, so let's call this regression analysis. Regression analysis. All right. So under the regression analysis, what do we do? I think the first thing we need to do is to state the regression analysis formula. All right. So let's say the formula. All right. So we know we're calculating for variable cost and for fixed cost. So let's take the formula for the fixed cost first, which is A equals to, so in our cost, and let me put the cost line here, total cost line here, which is Y equals to, and Y is total cost, A plus BX. All right, that's what we use for the high and low. And that's exactly what we use also for the regression analysis. So our A, the formula for calculating A is the summation X, sorry, summation Y all over N minus B summation X all over N. That's the formula for A, which is our fixed cost. And so for B, of course, in order to calculate A, we need to calculate B first. All right, so for the B, we have N summation XY minus summation X summation Y all over N summation X squared minus open bracket summation X close bracket squared. All right, so using this formula, we can calculate our A and calculate our B, and at the end of the construct our total cost line. So let's calculate B first. No, we have to calculate B first before we can calculate A. All right, so let's calculate B first. But in order to calculate B, we need to do our table. Now let's look at this formula. We will need summation Y, we will need summation X, we will need summation XY, and we will need summation X squared. All right, so let's do our table. We have months. We have output. And this output will be our X. And then we have cost. And this cost will be our Y. We have XY, which will help us calculate summation XY. And we have X squared, which will also help us calculate our summation X squared. All right. So let's get the figures down. So we have the months as January, February, March, April, May, and June. All right. So our output 5.8, 7.7, 8.2, 6.1, 6.5, 6.5, 7.5. All right. So, okay, so for the cost, we have 40.3, 47.1, 48.7, 40.6, 44.5, and 47.1. Okay, for XY, now XY is the output multiplied by the cost. That's 5.8 multiplied by 40.3 for January. Okay, that's 233.74. Okay, 362.67. 399.34. 247.66. 289.25. And 353.25. So that's our XY. Now our X squared is just 5.8 multiplied by 5.8 for January. So that's X squared. 5.8 squared. That's the 3.64. 59.29. 67.24. 37.21. 42.25. 56.25. Okay, so let's sum everything. Can sum everything now. So we have our summation. All right. For X, which is the output, is 41.8. For cos, which is Y, is 268.3. 268.3. For XY, 1885.91. 1885.91. And then for X squared is 295.88. 295.88. All right. Wow. We've almost finished doing our calculation. So now we can fill in the gap. All right. So for our B, we can substitute in the formula. And then most importantly, our N is equal to 6. How did we get that? We have January, February, March, April, May, and June. So we have a set of data for 6 months. So our N is 6. Okay. So let's substitute the figures in our equation for B. So B is equal to N. Let's say B. Since we're calculating B first, so that will be B equals to N. What is N? 6 multiplied by summation XY. What's summation XY? Let me just push the page a little bit up. All right. Summation XY is 1885.91. Let's close the bracket so we can have some level of sanity over there for the figures. So we have summation X, summation Y. Now summation X is 41.8. And what's summation Y? Summation Y is 268.3. 268.3. Okay. All divided by N summation X squared. What's N? 6 multiplied by what's X squared? X squared is 295.88. 295.88. We can put that in bracket also to help. All right. The next one is now summation X close bracket square. What's summation X? That's 41.8. Close the bracket square. Okay. We're getting there. Little by little steps. Getting us there. B equals to, so let's open the bracket here. 6 times 1, 885, and let me put a comma here. 0.91 gives us 11315.46. Okay, minus 41.8 multiplied by 268.3 gives us 11214.94. 11214.94 divided by 6 times 298.88 gives us 1775.28. 1775.28 minus 41.8 squared gives us 1747.24. 17 47.24. 77.24. All right, so our B is equal to, so when you minus this from this, we have 100.52 divided by 28.04. And that gives us how much? $3.5. And you can call that variable cost per unit. Okay. Now for A, our A will now be equal to, let's look at the formula, summation Y all over N. What's summation Y? Summation Y is 268.3. So that's 268.3 divided by N, which is 6, minus B, what's B? 3.58 multiplied by summation X. What's summation X? Summation X is 41.8. 41.8 divided by also N, 6. So our A will be equal to 268.3 divided by 6 gives us 44.72. 44.72 minus, by the time you divide this, solve this, 3.58 multiplied by 41.8 divided by 6 gives us 24.94. 24.94. And so our A, which is our fixed cost, will be 19.78. All right, and that's our fixed cost. Okay, so our stock cost line, or the line of best fit as it were, our total cost line will be equal to 19.78 plus 3.58 x. Okay, that's our total cost line. Thank you very much, and see you in the next class.